Okay, in this video we're going to be looking at graphs of exponential functions. And in our first example it says identify the initial value, the growth or decay factor, and the growth or decay rate for each of the three equations listed. Then enter the equations into your calculator and sketch their graphs on the axis. Okay, so I want to identify each of these, the initial value, the growth or decay factor. So for number 1, I can see my initial value is 100. It's the value of my A parameter. Growth or decay factor, well, I can see this is going to be a growth factor because it's greater than 1. My B value is greater than 1. So my growth factor is 1.2. And since I have a growth factor, I also have a growth rate. My growth rate is going to be 0.2 or 20%. Remember, the growth factor is equal to 1 plus the growth rate. So if my growth factor is 1.2, that means my growth rate must be 0.2 or 20%. Second function, my initial value is 50. My growth or decay factor, well, I've got the same as in the previous one. So this is a growth factor of 1.2, a growth rate of 0.2 or 20%. In this third function, my initial value is 25. And again, I have the same growth factor and growth rate as before, 1.2, 0.2, or 20%. Okay, next it says, actually it says enter the equations in your calculator and sketch their graphs. I can actually sketch the graphs even without entering these functions into my calculator, just using what I know about the parameters of an exponential function, these values of A and B. So I can see that my initial value for each of these functions, I've got 3 different initial values. So let me go ahead and graph what these initial values are going to be. Remember, the initial value is just the value of a function when x is equal to 0. In other words, that's the y-intercept or vertical intercept. So 25, 50, and 100, let's see, let's say 100 is right here, and 50 is right here, and 25 is right here. So each one, this is the starting point for each one of my graphs. And since each one of them has the same growth rate of 20%, I know that all of my graphs are going to be increasing because they have a growth rate, and they're all going to be increasing at exactly the same rate, which means this one, let's say it goes up looking like that, this one is going to look exactly the same, it just starts in a different place. This one's also going to look the same, it just starts in a different place. All right, example number 2. Again, identify the initial value, the growth and decay factor and rate, and sketch the graphs of these axes. Okay, so my initial value for this function is 50. My growth or decay factor, again, I can see it's going to be a growth factor because it's greater than 1. Growth factor is 1.4. Growth rate then is going to be 0.4 or 40%. Initial value, again, is 50. In fact, I can see my initial value for all 4 of these is going to be 50. Growth or decay factor. All right, again, I've got a growth factor because it's greater than 1. That's 1.2. And a growth rate then is going to be 0.2 or 20%. This third function, let's see, I've got my initial value of 50, growth or decay factor. Now this one I can see is going to be a decay factor because its value is less than 1. So my decay factor is 0.8. And now my decay rate, the decay rate, remember decay factor is equal to 1 minus the decay rate. So if my decay factor is 0.8, my decay rate must be 0.2 or 20%. Function number 4, my initial value is 50. Again, I've got a decay factor because it's less than 1. My decay factor is 0.6. And my decay rate must be 0.4 or 40%. Okay, so now I've got all of my information here filled in the blanks. Let me see if I can sketch these functions. Again, even without entering them into my calculator, I can use what I know about my parameters, A and B, and my growth and decay rates to sketch these functions. So each one of them has exactly the same initial value, so I know they're all going to start at the same y-intercept. Now these first two, y1 and y2, I see that they both have a growth rate a growth factor, which means they're going to be increasing. This one, y1, I notice has a growth rate of 40%. This one has a growth rate of 20%. So function y1 is going to be increasing at a higher rate. So it's going to be increasing more quickly than this one that's only increasing at a 20% rate. So my y1 function, it's going to go up at a faster rate than my y2 function. y2 is also going up, it's just not going up as quickly. So there's y1 and y2. y3 and y4, I notice, are both decaying, which means they're going to be decreasing. Those graphs are going to be decreasing. This one, y3, I notice decreases at a rate of 20%. y4, however, is decreasing at an even higher rate. It's decreasing even more quickly. So y4 is going to start here, and it's going to decrease very quickly. y3 is going to start at the same place. It's also going to decrease, but not as quickly as the one for y4. So here's y4, which decreases at the greatest rate. And this is y3, also decreasing, but not at quite as high a rate. So part 3a here, it says, for the equations in example 1, how do the graphs change when you change the initial value? Well, the way they change is the graphs, I'm going to say they slide up or down. In other words, all the graphs in example 1, they had the same growth rate. So the shape of the graph is always the same. It's going up at the same rate. They just start at a different place depending on what their initial value is. Part B says, for the equations in example 2, how would you describe the graph of an exponential equation that has a growth or decay factor greater than 1? Well, if it has a growth or decay factor greater than 1, then that's going to mean that the graph is increasing. And similarly for part C, for the equations in example 2, how would you describe the graph of an exponential equation that has a growth or decay factor less than 1? Well, if its factor is less than 1, then that is a decay factor, which means its graph is decreasing. Part D, if you have two exponential graphs that both have a b value greater than 1, which graph will be increasing more quickly? Well, the one that's going to be increasing more quickly is the one with the higher growth rate. That's going to be the one that's increasing more quickly. Now, part E is a similar question. If you have two exponential graphs that both have b values less than 1, which one will be decreasing more quickly? The one that will be decreasing more quickly is the one with the higher decay rate. And now this is important because notice that here we're talking about the one with the higher decay rate, which is not necessarily the one with the higher decay factor. So let's take a look at example number 4. And hopefully this will make that clear. Example number 4. Identify the initial value, growth decay factor, growth decay rate, just as we did before. And then match each of these 4 equations with their graphs given here. Okay, so let's fill in these blanks here. Initial value 100, growth, this one is a growth factor of 1.1, so it's a growth rate of 0.1 or 10%. This one, initial value of 100, again it's a growth factor 1.3, which means it's a growth rate of 0.3 or 30%. Y3, initial value of 75, growth or decay. All right, this one has a decay factor since it's less than 1. Decay factor is 0.5. And its decay rate is going to also be 0.5 because that's 1 minus 0.5. So 0.5 or 50%. And Y4, initial value 75. Growth or decay, this one is a decay factor because it's less than 1. 0.75. And the decay rate, in this case, is going to be 0.25, or 25%. Okay, so there's each of those values. Now let's see if we can match up each one of these equations with the graphs. Okay, so I can see I have two graphs here that have an initial value of 100. That must be these two equations right here. One of them is going to be y1 and one is going to be y2. One of the graphs I see is increasing more quickly than the other one, which tells me that this one on the top, it's increasing more quickly, so it must have a higher growth rate. So the one of these two functions that has the higher growth rate is this one, y2. So y2 is increasing at a higher rate. So this graph must correspond to y2, which means this graph must be y1. Okay, each of these two graphs has an initial value of 75, so that must be y3 and y4. So let's see, one of these graphs is decreasing more quickly, which means it has a higher decay rate. So this one that has the higher decay rate, let's see, one of them has a decay rate of 25%. This one has a decay rate of 50%, so this must be the one that is decreasing more quickly, which means this must be y4.